in next part of the previous chapter. Here today we will discuss about integration. So what is integration? Integration is just a reverse process of differentiation. If let we have function f of x, and on differentiating this we get another function g of x. Then this function f of x is called integration of function gx, which is symbolized or denoted as this. So if by differentiation of this function we get this, then by integrating this we again get this function. So thus the integration is just a reverse process of differentiation. Integrations are of two types: indefinite integration and definite integration. First we understand indefinite integration. Let we have a function f of x plus constant c, and if I differentiate it d by dx, then I get g of x. As we know that the differentiation of constant will be 0. So now if I integrate this, then what happened with this constant? So in the integration we have a uncertainty of a constant. So if I perform the integration of this, then I will write g of x dx is equal to f of x plus integration constant c. The second type of integration is definite integration. If when we integrate any function, we know that within these two limits I have to integrate this function, like I have function gx dx integration, and I want to integrate this function within the limit a to b. Then this integration is called definite integration. Here a is called lower limit, b is called upper limit. If we change the limit, if we place b here and a here, then a minus sign will be added. So if integration of this function give us f of x, then this limit will be written as b. Now one time place here b and one time write this function in form of a. B value minus a value. So this is called definite integration. We will understand both of this time by some formulas and example. So here is the rules of integration. Integration of constant with respect to dx gives us constant multiplied by x plus c, where c is integration constant. Integration of x to the power n dx gives us x to the power n plus 1 divided by n plus 1 plus c, where n not equal to minus 1. Integration of 1 upon x with respect to dx give us log x plus c, where c is integration constant, and so on. The value of integration constant c is decided by the initial condition of given problem. Here I have choose 3 examples and we will understand them. In the first example, we have to integrate this function. This is indefinite integration, so we will place a integration constant. So here it becomes integration of 2x to power 3 minus integration x to power 2 plus, sorry, 2x to power 3 dx minus integration x to power 2 dx plus integration 5 dx. This 2 is constant, so it will comes out, and x to power 3 by this rule it become 2 multiplied by x to power 3 plus 1 divided by 3 plus 1 minus integration of x to power 2, and it become x to power 2 plus 1 divided by 2 plus 1 plus 5 dx. The constant multiplied by dx, it become constant multiplied by x, so it will be 5x. Now this become 2x to power 4 divided by 4 minus x to power 3 divided by 3, 5x, or x to power 4 divided by 2 minus x to power 3 divided by 3 plus 5x plus integration constant c. So this is our result. So in the next example, we want to integrate this function for limit r to infinite. Since this is an example, or this is, we familiar with this thing, this is the formula of gravitational force in which g, m and small m are constant, so it will comes outside g, m, small m. This x, if we take it to up, it becomes x to power minus 2 dx. Now, by the formula of the integration, it will be g m small m x to power minus 2 plus 1 divided by minus 2 plus 1 r to infinite. It will be g m small m minus 2 plus 1 minus 1, so minus 2 plus 1 minus 1, so x to power minus 1, it will be 1 upon x r to infinite. At first we place here infinite and minus, second time we place here r. Then we get minus g m small m multiplied by 1 upon infinite minus 1 upon r. Since the value of 1 upon infinite is 0, so we get only y minus 1 upon r. This minus will cancel this, so our result will be g m small m divided by r. In the last example, we want to integrate this for our limit 3 to 5. So this 2 is constant. Integration of 3 to 5 x dx, it will become x to power 1, so 1 plus 1, 2, divided by 1 plus 1, 2, 3 to 5. X, at x we place 5, so divide by 2 minus divide by 2. This 2 will become at outside, so 1 upon 2 is since common, so this 2 will be cancelled by this, and the square of 5 is 25 minus square of 9 is 9, and we get answer 16. So our next topic is integration and graphical representation. In this topic we will understand what is the use of integration. For an example, let we have a function y is f of x, and this function have a graph this, If we want to find the area under the graph, then what we will do? We will drop a perpendicular here, and now we can find this area. Let this distance is x, this is y, then the area of this triangle will be y. So in this case, the area can be found easily. But what if the function have a graph like this or this? So in this graph, if we want to find the area, then our knowledge of small class will not help us. So for finding the area, this graph is beginning from here, and here the x coordinate is let x1 and end at here, and here x coordinate is x2. Now for finding the area, let we choose a rectangular strip on this graph. Here I have created three rectangular strips of length thickness del x and a height of y. Then the area of this strip will be y del x. If similarly we divide the whole area in rectangular strip, then by adding all the area of strips, we can find the complete area. But in this process, some area will be left like this. This area, this area. For including this area, we will narrow our strip like this, and let the now thickness is dx. Then the area of the one strip will be y dx. But again, small amount of area will be left. For including this area, we have to narrow our strip extremely small, near to 0. So in this case, we get lot of strip in this area, and by adding the area of all strips, we will get our complete area. So we have to add all area of all the strips. In this case, we will add this by integration y dx, where y dx is area of one strip, and we are doing this between x1 to x2. So our limit will be x1 to x2. So by using this, we can get the complete area of this. Later in other chapters, we will use this in our applications.